Right now, as you sit watching this video, you are imprisoned. Not by walls you can see or touch, but by invisible barriers woven into the very fabric of space itself. These walls aren't made of matter or energy. They're made of geometry, of curved spacetime that bends reality into shapes that trap us more completely than any physical cage ever could. We've always believed that space is empty, that if we could just build fast enough ships or wait long enough, we could go anywhere in the universe. We imagined that the only limits were technological fuel, speed, time. We were completely wrong about the fundamental nature of our cosmic prison. Here's what makes this truly disturbing. These invisible walls aren't distant theoretical concepts. They're here, right now, pressing against every atom in your body. The gravitational field of Earth isn't just pulling you down. It's warping the shape of space-time around you, creating barriers that determine what futures are possible and which are forever forbidden. You can't see these walls. You can't feel them directly, but they govern every motion you will ever make for the rest of your life. The mathematics behind this cosmic imprisonment are staggering. Einstein's field equations reveal that every massive object doesn't just create gravity, it creates horizons. Invisible boundaries in space-time, beyond which certain regions of the universe become unreachable, no matter how much energy you possess or how much time you have. We exist in pockets of space-time, separated by barriers as impenetrable as the event horizon of a black hole. Leading gravitational physicists like Kip Thorne and Carlo Rovelli have mapped these hidden walls with increasing precision. Their calculations show that we are not just physically separated from distant galaxies. By expanding space, we are causally disconnected by the geometry of space-time itself. There are regions of the universe that have already slipped beyond invisible horizons, becoming permanently inaccessible regardless of any future technological breakthrough. But perhaps the most profound realization is this: these walls don't just limit where we can go. They define what we can become. The curvature of space-time around massive objects creates causal boundaries that determine which events can influence which other events. Your future isn't just constrained by physics. It's geometrically carved out by invisible walls that separate possible futures from impossible ones. Tonight, we're going to explore the architecture of cosmic imprisonment. We'll discover how gravity creates barriers more absolute than any material wall, why some parts of the universe have already become unreachable forever, and what it means to exist as conscious beings trapped in pockets of curved spacetime. We'll examine the mathematics of horizons, the physics of causal boundaries, and the profound implications of living in a universe where invisible walls determine the ultimate limits of what is possible. This isn't just about space travel or distant galaxies. These invisible barriers shape every aspect of existence, from the orbital patterns of planets to the flow of time itself. They determine which stars will eventually become visible to us and which have already slipped forever beyond reach. They govern the ultimate fate of consciousness in a universe where geometric constraints override any conceivable technology. We'll journey through Einstein's greatest discoveries about the nature of spacetime, explore the strange physics of event horizons and cosmological boundaries, and confront the unsettling reality that we inhabit a universe of nested prisons, each defined by invisible walls that bend reality itself into shapes that constrain possibility. By the end of this exploration, you will understand why some of the greatest minds in physics describe our cosmic situation not as unlimited exploration potential, but as geometric imprisonment within space-time structures that create absolute, unbreachable barriers between different regions of reality. If you're ready to discover the invisible architecture that constrains everything that has ever existed or ever will exist, subscribe and hit the thumbs up button. And here is a question that will haunt you after tonight. If you could see the invisible walls that surround you right now, would you still feel free? Share your thoughts in the comments. I'll pin the most thought-provoking response. The mathematics of cosmic imprisonment are about to reveal why we are all permanent prisoners of geometry itself, trapped by forces we cannot see and walls we cannot cross. What you're about to learn will forever change how you think about space, time, and the ultimate nature of freedom in a universe built from invisible barriers. Now let's begin our journey into the cosmic prison that surrounds us all. Chapter 1. Curved Prison. You're sitting in a gravitational prison right now, and you don't even know it. The chair beneath you isn't just supported by electromagnetic forces between atoms. It's suspended in a curved geometry of space-time that creates invisible walls, more absolute than steel, more permanent than diamond, more inescapable than any physical barrier ever conceived by human engineering. Einstein's 1915 field equations revealed something extraordinary about the nature of reality itself. Mass and energy don't just exist in space-time. They actively warp its geometry, creating curves and valleys and peaks in the four-dimensional landscape of existence. But here's what makes this discovery so profound. Those curves aren't just mathematical abstractions. They're physical barriers that determine which paths through space-time are possible and which are forever forbidden. Consider what's happening to you right now. Earth's gravitational field has curved the space-time around you into a deep well. Every direction you could possibly move up, down, sideways, even forward through time, is constrained by this curved geometry. You experience this as weight, as the force pulling you toward the ground. But the deeper reality is that you're trapped in a valley of curved space-time, unable to escape without providing enough energy to climb up the walls of this invisible gravitational well. The mathematics are staggering in their precision. Einstein's field equations, G equals 8t, describe exactly how mass energy creates curvature in space-time geometry. The left side represents the curvature, the shape of your invisible prison. The right side represents the mass and energy that creates this curvature, Earth itself, warping the fabric of reality around it like a bowling ball pressing down on a stretched rubber sheet. But unlike a rubber sheet analogy, space-time curvature exists in 4 dimensions, not 2. This means the walls of your gravitational prison extend not just through space, but through time itself. Your future is literally carved out by the geometry of curved space-time. Certain futures become geometrically impossible, not because of technology limitations, but because the shape of space-time itself forbids those paths through 4-dimensional reality. NASA's Gravity Probe B mission, launched in 2004, measured these curved walls with extraordinary precision. The satellite carried gyroscopes so sensitive they could detect how Earth's rotation drags space-time itself, creating additional curvature that twists the invisible walls of our gravitational prison. The measurements confirmed Einstein's predictions to better than 1%, proving that we truly inhabit a universe where massive objects create geometric barriers in the fabric of reality itself. To understand the full scope of your imprisonment, imagine trying to escape Earth's gravitational well. You need to provide enough energy to climb up the curved walls of space-time until you reach what physicists call the escape velocity, about 11.2 kilometers per second. But here's what's remarkable. This isn't just about overcoming a force. You're literally climbing up a geometric slope in 4-dimensional space-time, using energy to change your position in the curved landscape of reality itself. The deeper you go into a gravitational well, the steeper the walls become. Near the surface of a neutron star, space-time curvature becomes so extreme that the walls of the gravitational prison approach the ultimate geometric limit. Time itself slows down, space contracts, and the barriers between your location and the rest of the universe become nearly insurmountable. You're trapped not just physically, but causally. The curved geometry delays and distorts any communication with the outside world. But perhaps the most disturbing aspect of gravitational imprisonment is its absolute nature. Unlike physical walls that might theoretically be broken or circumvented, The curved geometry of spacetime cannot be altered without access to enormous amounts of mass energy. The walls of your gravitational prison are woven into the fundamental structure of reality itself. They're not barriers placed inside space and time. They are the shape of space and time. This creates a hierarchy of prisons within prisons. You're trapped in Earth's gravitational well, which is itself trapped in the Sun's much larger gravitational well, which is trapped in the Milky Way galaxy's vast gravitational architecture. Each level of imprisonment is defined by curved spacetime geometry that creates progressively larger but equally inescapable invisible walls. The European Space Agency, SLISA, Pathfinder mission has detected the gravitational waves that ripple through these curved prison walls. When massive objects accelerate through spacetime, they create waves in the geometric curvature itself, distortions that propagate at the speed of light, carrying information about the invisible walls that constrain cosmic motion. These gravitational wave detections prove that the curvature of spacetime is a dynamic, measurable aspect of physical reality. What makes gravitational imprisonment so profound is its universality. Every particle in the universe exists within multiple overlapping gravitational wells, each creating geometric constraints on possible motion through spacetime. From the quantum scale to cosmic scales, curved geometry defines the boundaries of what's possible and what's forbidden. You cannot step outside these curved walls to examine them from an external perspective. You cannot neutralize them or shield yourself from their effects. You are embedded within the curved geometry, and your very existence is shaped by the invisible barriers that surround you. The walls of your space-time prison are not something you encounter. They are something you inhabit, something that defines the geometric structure of your reality. As we delve deeper into the architecture of cosmic imprisonment, we'll discover that Earth's gravitational well is just the beginning. More extreme curvature creates more absolute barriers until we reach the ultimate geometric prison, regions of spacetime so curved that they create permanent walls between different parts of the universe, barriers that no amount of energy or time can ever breach. The invisible walls are everywhere, pressing in from every direction, carved into the very shape of existence itself. And now we must explore what happens when those walls become absolutely impassable. Chapter 2. Event Horizons. There are walls in the universe so absolute that once you cross them, the geometry of space-time itself guarantees you can never return. These aren't theoretical boundaries or distant philosophical concepts. They real geometric surfaces where the curvature of space and time creates the ultimate one-way barrier. Welcome to the mathematics of event horizons, where invisible walls become permanently impermeable. An event horizon represents the most extreme form of gravitational imprisonment imaginable. It's a spherical surface in spacetime where the escape velocity reaches exactly the speed of light. But here's what makes this boundary so profound. Since nothing can travel faster than light, nothing, no particle, no information, no causal influence of any kind, can ever escape from inside this geometric wall once it's been crossed. The Schwarzschild radius defines the location of this invisible barrier with mathematical precision. For any spherically symmetric mass, the event horizon forms at a distance of rs equals 2gm per c squared, where g is the gravitational constant, m is the mass, and c is the speed of light. This isn't just a formula, it's the blueprint for the most absolute wall that physics allows. A geometric boundary carved from pure spacetime curvature. Consider what happens as you approach a stellar mass black hole like Cygnus X1, located about 7,200 light-years from Earth. As you descend into the increasingly curved spacetime around this 20 solar mass object, the invisible walls of the gravitational prison become progressively steeper. But unlike ordinary gravitational wells, this one has a special geometric property. At the Schwarzschild radius of about 60 kilometers from the center, spacetime curvature becomes so extreme that it creates a one-way membrane in reality itself. The Event Horizon Telescope collaboration, led by scientists like Katie Bouman and Shepard Dolman, has captured direct images of these invisible walls. Their 2019 photograph of the supermassive black hole in galaxy M87 shows the shadow cast by an event horizon, the silhouette of a region where space-time curvature has become so extreme that it creates an absolute barrier to light itself. We're literally seeing the shadow of invisible geometric walls that trap everything, including the photons that would normally allow us to observe what lies beyond. But the physics of event horizons reveals something even more disturbing about the nature of these invisible barriers. From the perspective of someone falling through an event horizon, nothing unusual happens at the moment of crossing. The local curvature of space-time feels finite, and they continue falling inward toward the central singularity. However, from the perspective of any external observer, time dilation effects mean that the falling person appears to slow down and freeze at the horizon, their image gradually redshifting and fading away. This creates what physicists call the information paradox. The event horizon acts as a one-way valve that allows information to flow inward but never outward. Stephen Hawking's calculations suggested that black holes should eventually evaporate through quantum radiation, but this seems to violate the fundamental principle that information cannot be destroyed. The invisible walls of event horizons create boundaries that challenge our understanding of causality, thermodynamics, and the conservation of information itself. The gravitational time dilation near event horizons creates additional layers of invisible imprisonment. GPS satellites orbiting Earth must account for time dilation effects of about 38 microseconds per day, a tiny effect of Earth's relatively weak gravitational field. But near a black hole's event horizon, time dilation becomes extreme. What feels like minutes to someone near the horizon corresponds to thousands of years for distant observers. The invisible walls don't just trap matter and energy, they trap time itself. LIGO and Virgo gravitational wave detectors have recorded the signatures of event horizon mergers with unprecedented precision. When two black holes spiral into each other, their event horizons eventually touch and merge, creating a larger combined horizon. The gravitational waves detected from events like GW150914 carry information about how these invisible walls reshape and recombine, providing direct observational evidence of event horizon dynamics. The mathematical description of event horizons reveals their true geometric nature. The Schwarzschild metric, ds equals 1 RSRC YDT plus 1 RSR YDR squared plus R YD, shows how spacetime curvature creates coordinate singularities at the event horizon. These are unphysical singularities. They are mathematical artifacts that reveal how the geometry of spacetime creates absolute barriers between causally disconnected regions. Recent theoretical work by physicists like Juan Maldacena and Leonard Susskind suggests that event horizons might be connected to quantum entanglement in ways that challenge traditional views of spacetime geometry. Their equals EPR conjecture proposes that Einstein-Rosen bridges, wormholes, connecting distant regions of spacetime might be equivalent to Einstein-Podolsky-Rosen quantum entanglement between particles. If true, this would mean that the invisible walls of event horizons are fundamentally connected to the quantum mechanical structure of reality itself. But event horizons aren't limited to black holes. The accelerating expansion of the universe creates a different type of invisible barrier called a cosmological event horizon. Due to dark energy driving cosmic acceleration, there's a maximum distance beyond which light emitted today will never reach us, no matter how long we wait. This creates a spherical wall around our observable universe, beyond which information becomes permanently inaccessible. The physics becomes even more exotic when we consider rotating black holes described by the Kerr metric. These objects create additional invisible barriers called ergospheres, where spacetime itself is dragged around the rotating mass. Inside the ergosphere, but outside the event horizon, it becomes impossible to remain stationary relative to distant stars, spacetime curvature forces everything to rotate along with the black hole, creating a region where the geometry of space and time constrains motion in previously unimaginable ways. Quantum field theory in curved spacetime reveals that event horizons have temperature and entropy, properties usually associated with thermodynamic systems rather than geometric boundaries. Jacob Bekenstein and Stephen Hawking demonstrated that the entropy of a black hole is proportional to the area of its event horizon, not its volume. This suggests that the invisible walls of event horizons contain information about the quantum states of all matter that has ever fallen through them. The Planck collaboration S measurements of the cosmic microwave background have mapped the largest invisible walls of all the cosmological horizons that define the limits of the observable universe. These barriers aren't created by mass concentration, but by the expansion history of spacetime itself. They represent absolute limits to observation and causal connection, walls that define the maximum scope of what any observer can ever hope to detect or influence. As you contemplate these invisible barriers, remember that event horizons represent the extreme limit of gravitational imprisonment. They're regions where spacetime curvature becomes so severe that it creates one-way membranes in reality itself, permanent walls that separate causally connected regions from causally disconnected ones. But even these ultimate barriers are just one type of invisible wall that constrains cosmic existence. The universe contains other geometric boundaries that limit possibility and define the architecture of cosmic imprisonment. We must now explore how the expansion of space itself creates moving walls that continuously shrink the realm of the accessible ... Chapter 3. Cosmological Boundaries. The universe is expanding, and as it expands, it's constantly creating new invisible walls that forever separate us from vast regions of cosmic reality. These aren't walls we might someday break through with better technology. They read geometric, boundaries written into the fabric of spacetime itself, barriers that grow larger and more impenetrable with every passing second. The Hubble constant, currently measured at approximately 67.4 kilometers per second per megaparsec by the Planck satellite, describes the rate at which space itself expands. But this isn't just about galaxies moving apart. It is about the continuous creation of invisible barriers that define what parts of the universe we can ever hope to observe, visit, or causally influence. Every moment that passes, more of reality slips forever beyond these expanding walls. Consider the particle horizon, the invisible spherical boundary that defines the observable universe. Light from objects beyond this horizon simply hasn't had enough time to reach us since the Big Bang occurred 13.8 billion years ago. This creates a wall approximately 46.5 billion light-years in radius larger than the age of the universe in light-years, because space itself has been expanding while that ancient light traveled toward us. Beyond this invisible barrier lies a realm of galaxies, stars, and possibly civilizations that are completely cut off from any information exchange with our region of spacetime. But the expanding universe creates an even more absolute form of cosmic imprisonment through what cosmologists call the event horizon. Due to the accelerating expansion driven by dark energy, there's a maximum distance, currently about 16 billion light-years beyond, which light emitted today will never reach us, no matter how long we wait. This creates a spherical wall that defines the ultimate limit of future observability. Galaxies beyond this cosmological event horizon are slipping away from us so rapidly that they're recrossing a one-way barrier in spacetime, disappearing forever behind an expanding invisible wall. The Wilkinson Microwave Anisotropy Probe and Planck satellite have mapped the cosmic microwave background with extraordinary precision, revealing the imprint of sound waves that traveled through the primordial plasma before the universe became transparent, 380,000 years after the Big Bang. These measurements show us the earliest observable boundary, the surface of last scattering, an invisible spherical wall that represents the limit of electromagnetic observation. Before this boundary, the universe was opaque to photons, creating an absolute informational barrier to earlier epochs. Recent observations by the James Webb Space Telescope have detected galaxies that formed when the universe was only 400 million years old, pushing closer to the fundamental observational barriers created by cosmic expansion. But these discoveries also reveal how the expansion of space creates temporal walls, epochs of cosmic history that become progressively more difficult to observe, as their light becomes increasingly redshifted and stretched by the expanding spacetime through which it travels. The mathematics of cosmic expansion reveals multiple nested invisible barriers. The Hubble distance, dH equals CHO, currently about 14.4 billion light-years, represents the distance at which the recession velocity of space equals the speed of light. Beyond this invisible wall, galaxies are receding faster than light, not because they're moving through space faster than light, but because the space between us and them is expanding fast enough to create this geometric separation. Dark energy, comprising about 68% of the universe's total energy density, is continuously accelerating cosmic expansion and thereby strengthening these invisible barriers. Type Ia supernova observations by teams led by Sol Perlmutter, Brian Schmidt, and Adam Rees revealed this acceleration in 1998, demonstrating that the walls separating us from distant regions of the universe are not just present, they reactively growing stronger over time. The de Sitter spacetime that describes our accelerating universe contains mathematical horizons that create permanent causal boundaries. In de Sitter coordinates, observers are surrounded by event horizons similar to those around black holes, but created by cosmic acceleration rather than gravitational collapse. These cosmological horizons define spherical walls beyond which no causal influence can ever be transmitted or received. Large-scale structure surveys like the Sloan Digital Sky Survey have mapped the cosmic web of galaxies and dark matter filaments, revealing how expansion creates evolving boundaries between gravitationally bound structures and regions dominated by cosmic expansion. Galaxy clusters and superclusters exist in gravitational wells deep enough to resist expansion, but the space between them continues to expand, creating an ever-growing network of invisible walls that isolate these structures from each other. The concept of cosmic inflation, proposed by Alan Guth and refined by Andre Lind and others, suggests that our observable universe represents a tiny fraction of a vastly larger inflating spacetime. If inflation occurred, then beyond our particle horizon lies not just more of the same kind of space we observe locally, but potentially infinite regions with different physical constants, different histories, and fundamentally different evolutionary pathways. The invisible walls created by inflation separate us from a multiverse of causally disconnected cosmic domains. Measurements of the cosmic microwave background by the Planck collaboration have revealed that the universe is geometrically flat to within 0.4%, which has profound implications for the ultimate nature of cosmological boundaries. In a flat universe with accelerating expansion, the event horizons that define the limits of causal connection will continue to exist indefinitely, creating permanent walls between different regions of cosmic spacetime. The anthropic principle suggests that we might live in a region of spacetime with physical constants fine-tuned for the existence of complex structures and conscious observers. If true, then the invisible walls created by cosmic expansion separate us not just from other galaxies, but from regions where different physics might apply, cosmic domains where stars, planets, and life might be impossible due to different values of fundamental constants. Quantum field theory in expanding spacetime reveals that the accelerating cosmic expansion creates particle production through the Unruh effect. Empty space in an accelerating reference frame appears to contain thermal radiation, suggesting that the invisible boundaries created by cosmic acceleration have thermodynamic properties similar to event horizons around black holes. The cosmological event horizon has an associated temperature of about 10 Kelvin, unimaginably cold but theoretically detectable. The Big Rip scenario, one possible fate for our accelerating universe, would eventually strengthen these invisible barriers until they tear apart all bound structures. If dark energy continues to accelerate expansion at an increasing rate, the cosmological event horizons would shrink until they separate neighboring galaxies, then solar systems, then planets, and eventually even atoms. The invisible walls would become so strong that they would overcome all fundamental forces, creating ultimate cosmic imprisonment at every scale. Recent theoretical work on eternal inflation suggests that our Big Bang might represent just one bubble in an eternally inflating multiverse. If true, then the cosmological boundaries we observe locally are nested within much larger invisible walls that separate different inflating regions, each with potentially different physics and evolutionary histories. We would be imprisoned not just within our expanding cosmic horizon, but within one bubble of spacetime among an infinite collection of causally disconnected cosmic domains. As you consider these expanding invisible walls, remember that they represent the most fundamental form of cosmic imprisonment, separation created not by the presence of matter or energy, but by the geometric properties of spacetime itself. The universe is continuously creating new barriers that define what can ever be observed, visited, or influenced by conscious beings anywhere within our cosmic domain. But cosmological boundaries are just one aspect of the invisible architecture that constrains existence. We must now explore how the speed of light itself creates absolute walls that limit the transmission of information and causal influence. Chapter 4. Light speed barriers. The speed of light isn't just a universal speed limit. It is the fundamental architecture of invisible walls that separate events in spacetime, creating absolute barriers between cause and effect that no technology or energy expenditure can ever breach. These light speed barriers define the geometric structure of causality itself, determining which events can influence which other events and carving reality into causally connected and causally isolated regions. Einstein's special relativity revealed that the speed of light in vacuum, precisely 299,792,458 meters per second, represents more than just the velocity of electromagnetic radiation. It's the fundamental speed at which causality propagates through spacetime, the maximum rate at which information, influence, or causal connection can travel between different points in the universe. This creates invisible walls called light cones that divide spacetime into accessible and inaccessible regions for every event that has ever occurred or ever will occur. Consider your current moment in spacetime. Around this event, there exists an invisible double cone structure that defines the absolute limits of causal possibility. The past light cone contains all events that could potentially influence your current moment. Everything within the geometric boundary defined by light signals that could have traveled from those events to reach you now. The future light cone contains all events that your current moment could potentially influence. Everything within the boundary that light signals from your current position could reach. Outside these light cones lies the Losware region, a vast domain of spacetime events that are causally disconnected from your current moment. These aren't distant places you might visit someday with better technology. They're geometric impossibilities, events separated from your current moment by invisible barriers that prevent any causal connection, regardless of energy expenditure or time duration. The speed of light creates absolute walls in the structure of spacetime itself. The Lorentz Transformation mathematics reveal how these light-speed barriers reshape reality for observers in relative motion. As velocities approach the speed of light, time dilates and space contracts, according to the formulas gamma equals 1 square root 1v squared per c squared, where gamma is the Lorentz factor. This isn't just about clocks running slowly or rulers shrinking. It is about the geometric deformation of light cones themselves, changing the shape of the invisible walls that define causally connected regions. Particle accelerators like the Large Hadron Collider routinely accelerate protons to velocities exceeding 99.9999% the speed of light, demonstrating the reality of these light-speed barriers. As particles approach the ultimate velocity limit, their energy requirements increase toward infinity according to the relativistic energy formula E equals mc. The invisible wall at the speed of light becomes increasingly impenetrable as you approach it, requiring infinite energy to cross an absolute barrier that cannot be breached by any conceivable technology. The GPS satellite constellation provides daily proof of these light-speed barriers and their effects on the propagation of causal influence. GPS signals travel at the speed of light from satellites to receivers, but relativistic effects, including time dilation and gravitational redshift, must be precisely accounted for to maintain the system's accuracy. The invisible walls created by light speed limitations require constant correction factors that demonstrate how causality propagates through the curved geometry of spacetime. Quantum entanglement initially seemed to violate these light-speed barriers through spooky action at a distance, but subsequent analysis revealed that entangled particles cannot transmit information faster than light. Bell's inequality experiments, refined by physicists like Alan Aspect and John Clauser, confirm that quantum correlations are instantaneous but cannot be used to send signals across light-speed barriers. The invisible walls of causality remain intact even in quantum mechanical systems. The cosmic microwave background radiation, detected with extraordinary precision by satellites like COBE, WMAP, and Planck, represents the earliest electromagnetic signals that could propagate freely through space after the universe became transparent 380,000 years after the Big Bang. Before this epoch, the universe was opaque to light, creating an absolute informational barrier, an invisible wall that prevents electromagnetic observation of earlier cosmic history. The light-speed barrier combines with cosmic expansion to create this fundamental observational limit. Gravitational waves, detected by LIGO and Virgo interferometers, also propagate at exactly the speed of light, confirming that even ripples in space-time geometry cannot breach the fundamental causality barriers. The gravitational wave signals from merging black holes and neutron stars arrive at Earth after traveling for billions of years at light speed, demonstrating how these invisible barriers constrain the propagation of gravitational information across cosmic distances. Recent observations of fast radio bursts, FRBs, by telescopes like the Canadian Hydrogen Intensity Mapping Experiment provide additional evidence of light-speed barriers in action. These mysterious signals, possibly originating from magnetized neutron stars, travel across billions of light years and arrive at Earth after being delayed and dispersed by the invisible electromagnetic barriers created by intervening plasma and magnetic fields. The signals cannot arrive faster than the fundamental light speed limit allows. The mathematics of special relativity reveal that as you approach light speed barriers, not only does energy requirement approach infinity, but time dilation approaches infinite slowdown. A hypothetical spacecraft accelerating toward the speed of light would experience progressively more severe time dilation effects until, at the barrier itself, time would effectively stop from the perspective of external observers. The light-speed wall creates temporal imprisonment as well as kinematic impossibility. Causality violations would theoretically be possible if faster-than-light travel existed, creating closed time-like curves and grandfather paradox scenarios. The fact that such violations haven't been observed suggests that the light-speed barriers are fundamental features of spacetime geometry that preserve the logical consistency of cause and effect relationships. The invisible walls don't just limit velocity, they protect the coherence of physical reality itself. The Planck length, approximately 1.6 times 10 meters, represents the scale at which quantum effects might modify the classical picture of light-speed barriers. At these microscopic distances, quantum fluctuations in spacetime geometry might create temporary violations of causality, but these effects would be confined to scales far smaller than any observable phenomenon. The invisible walls remain impenetrable at all macroscopic scales. Astronomers studying active galactic nuclei have observed jets of plasma that appear to travel faster than light through a phenomenon called superluminal motion. However, detailed analysis reveals that these apparent violations of light-speed barriers are geometric illusions created by jets moving nearly at light speed but pointed almost directly toward Earth. The invisible walls remain intact. What appears to be faster than light motion is actually a projection effect that demonstrates how difficult it is to probe the ultimate velocity barrier. The search for tachyons, hypothetical particles that travel faster than light, has consistently yielded negative results, reinforcing the absolute nature of light-speed barriers. If tachyons existed, they would create causal paradoxes and allow information transmission into the past, violating the fundamental structure of spacetime causality. Their absence suggests that the speed of light represents an inviolable wall in the architecture of physical reality. Modern quantum field theory incorporates light-speed barriers through the requirement of Lorentz invariance, the principle that physical laws must respect the fundamental symmetries of spacetime. Violations of Lorentz invariance would create preferred reference frames and destroy the geometric elegance of relativity theory. Experiments testing Lorentz invariance, such as those conducted by the KTEV collaboration, have found no evidence of violations down to extraordinary precision levels. As you contemplate these invisible barriers, recognize that light-speed walls aren't just limits on travel or communication. They reveal fundamental features of spacetime geometry that define the structure of causality itself. Every moment of your existence is surrounded by light cones that determine which events can influence your future and which events your present moment can influence. The walls are invisible, but they're more real and more absolute than any physical barrier ever constructed. But light-speed barriers are just one aspect of the invisible architecture that constrains existence. We must now explore how quantum mechanics creates additional walls that limit what can be known, measured, or predicted about the fundamental nature of reality. Chapter 5: Quantum Walls at the Quantum Scale. Reality itself is built from invisible walls that prevent perfect knowledge, exact prediction, and complete measurement. These aren't temporary limitations waiting for better instruments. They are fundamental barriers woven into the mathematical structure of quantum mechanics, walls that ensure certain combinations of information about the universe can never be simultaneously known with absolute precision. Heisenberg's uncertainty principle, formulated in 1927, revealed the most fundamental invisible barrier in physics. XPP is greater than or equal to A2. This mathematical relationship describes an absolute wall between complementary properties of quantum systems. The more precisely you know a particle's position, the less precisely you can know its momentum and vice versa. This isn't about measurement limitations or technological constraints. It's about the quantum mechanical structure of reality itself, creating informational barriers that cannot be breached by any conceivable method. Werner Heisenberg's original insight came from analyzing the theoretical limits of measurement precision. To measure a particle's position exactly, you need to use light with infinitely short wavelength. which carries infinitely high energy and completely destroys information about the particle's momentum. To measure momentum precisely, you need light with infinitely long wavelength, which cannot localize position. The quantum world contains invisible walls that prevent simultaneous access to complementary information. The double-slit experiment, performed with electrons, photons, atoms, and even large molecules like fullerenes, demonstrates how quantum systems exist in superposition states until measurement forces them to choose definite properties. But here's what's profound. The act of measurement doesn't just reveal pre-existing properties. It creates an invisible barrier between the quantum and classical domains. Before measurement, particles exist in all possible states simultaneously. After measurement, this quantum superposition collapses behind a barrier that prevents direct access to the unmeasured quantum realm. Niels Bohr's principle of complementarity describes how quantum systems possess pairs of properties that cannot be measured simultaneously, not due to technical limitations, but due to the fundamental structure of quantum reality. Wave and particle descriptions, position and momentum, energy and time. These complementary pairs are separated by invisible walls that ensure complete knowledge of both aspects remains forever inaccessible to any observer. The quantum Zeno effect demonstrates how continuous measurement can freeze quantum evolution, creating temporal walls that trap quantum systems in specific states. Frequent measurements prevent quantum tunneling and state transitions, effectively building invisible barriers in time that constrain quantum mechanical processes. This isn't just theoretical. It has been demonstrated experimentally with trapped ions and has applications in quantum computing and quantum error correction. Schrodinger's cat thought experiment illustrates how invisible barriers separate quantum and classical domains. The cat exists in a superposition of living and dead states until observation forces classical reality to emerge from quantum possibilities. But the measurement process creates an irreversible barrier. Once you've observed the cat's state, you cannot return it to quantum superposition. The wall between quantum and classical reality is a one-way barrier that prevents macroscopic objects from displaying quantum behavior. Quantum entanglement creates invisible barriers of a different kind, walls that separate entangled systems from classical independence, while simultaneously connecting them through correlations that transcend spatial separation. Einstein, Podolsky, and Rosen identified this spooky action at a distance as a potential problem with quantum mechanics. But subsequent experiments have confirmed that entangled particles share correlations that cannot be explained by classical physics, even when separated by vast distances. Bell's inequality, tested experimentally by Alling Aspect and many others, proves that quantum entanglement creates correlations stronger than any classical theory allows. The invisible walls of quantum mechanics don't just separate us from perfect knowledge. They connect distant objects through non-local correlations that create barriers between quantum and classical descriptions of reality. Local realism itself is blocked by quantum mechanical walls. The no-cloning theorem in quantum mechanics creates absolute barriers to perfect quantum information duplication. Unlike classical information, which can be copied indefinitely without loss, quantum states cannot be perfectly cloned without destroying the original. This fundamental limitation creates invisible walls in quantum information processing that have profound implications for quantum cryptography, quantum computing, and our understanding of quantum measurement processes. Quantum tunneling demonstrates how particles can penetrate classical energy, barriers that should be impenetrable according to Newton's laws. Electrons tunnel through potential barriers in semiconductor devices, allowing modern electronics to function. Alpha particles tunnel out of atomic nuclei during radioactive decay. The quantum world contains invisible passages through classical walls, but these tunneling probabilities are governed by exponential suppression. factors that create their own quantum barriers to macroscopic tunneling effects. The measurement problem in quantum mechanics reveals fundamental barriers to understanding how classical reality emerges from quantum possibilities. Despite decades of research, physicists still debate whether wave function collapse is a real physical process or merely a change in an observer's information about the system. The invisible walls between different interpretations of quantum mechanics, Copenhagen, many worlds, the Broglie-Bohm, objective collapse theories prevent consensus about the fundamental nature of quantum reality. Quantum decoherence explains how interactions with the environment create barriers that separate quantum superposition from classical definiteness. Quantum systems lose their coherence through entanglement with surrounding degrees of freedom, creating irreversible barriers that make quantum superposition practically impossible for macroscopic objects. The environment itself creates invisible walls that confine quantum behavior to microscopic scales. The quantum measurement postulate introduces additional invisible barriers through the projection postulate, the assumption that measurement instantaneously collapses wave functions into definite states. This postulate creates mathematical walls in quantum theory that separate the unitary evolution of isolated quantum systems from the non-unitary collapse that occurs during measurement. These walls remain mysterious despite a century of quantum mechanical development. Quantum field theory extends these invisible barriers to the vacuum itself. The Casimir effect demonstrates how empty space contains quantum fluctuations that create measurable forces between conducting plates. The quantum vacuum isn't empty. It's filled with virtual particles that create invisible walls between different regions of spacetime. Zero-point energy, vacuum polarization, and spontaneous symmetry breaking all arise from quantum barriers built into the structure of apparently empty space. The holographic principle, emerging from black hole thermodynamics and string theory, suggests that information stored within any volume of space is limited by invisible barriers related to the area of the bounding surface rather than the volume itself. If true, this would mean that three-dimensional space contains fundamental informational walls that prevent it from storing arbitrary amounts of information, creating ultimate barriers to computational and informational density. Quantum error correction reveals how quantum information systems can overcome some quantum barriers through sophisticated encoding schemes that distribute information across multiple quantum degrees of freedom. But these error correction protocols create their own invisible walls barriers between error-correctable and uncorrectable quantum information degradation. Even the most advanced quantum computers must operate within fundamental limitations created by quantum mechanical barriers. The quantum-to-classical transition remains one of the most mysterious invisible barriers in physics. We understand quantum mechanics at microscopic scales and classical physics at macroscopic scales. But the precise boundary between these domains involves barriers that aren't fully understood. Proposals ranging from gravitational decoherence to conscious observation attempt to explain where and why quantum walls give way to classical reality. Recent experiments with quantum technology, from superconducting qubits to trapped ion systems to photonic quantum computers, continually probe the invisible barriers that separate quantum and classical domains. These experiments reveal that quantum walls aren't just theoretical constructs, but practical limitations that must be overcome through engineering sophistication. Quantum coherence times, gate fidelities, and error rates all reflect fundamental barriers imposed by quantum mechanical principles. As you contemplate these quantum walls, recognize that they represent barriers to knowledge itself, invisible boundaries that prevent complete information about reality from being simultaneously accessible to any observer. The quantum world doesn't just contain uncertainty as a temporary limitation waiting for better technology. It contains fundamental informational barriers that ensure the universe retains essential mysteries, regardless of measurement precision or computational power. But quantum walls are just one layer of the invisible architecture that constrains existence. We must now explore how thermodynamics creates additional barriers that limit the extraction of useful work and information from physical systems. Chapter 6. Thermodynamic Limits. The universe contains invisible barriers that prevent the perfect conversion of energy into useful work, creating walls that ensure all processes involve irreversible losses and that perfect efficiency remains forever impossible. These thermodynamic limits aren't engineering challenges waiting for better technology. They are fundamental walls built into the statistical structure of matter and energy that define what is possible and what is forbidden in any physical system. The second law of thermodynamics establishes the most universal invisible barrier in physics. Entropy always increases in isolated systems. This seemingly simple statement creates absolute walls that constrain every process in the universe, from the operation of engines and refrigerators to the formation of complex structures and the ultimate fate of cosmic evolution. Entropy increase isn't just a tendency, it is a mathematical certainty that creates irreversible barriers between past and future states of any system. Rudolf Clausius's formulation of entropy, S equals integral dQt, revealed how thermal processes create informational barriers that prevent perfect reversibility. Every heat transfer, every friction process, every spontaneous change creates invisible walls that separate the system's current state from perfect reversal to its previous configuration. These barriers accumulate over time, ensuring that the arrow of time points toward ever-increasing entropy and ever-decreasing available energy for useful work. The Carnot efficiency limit establishes absolute barriers to thermal engine performance. No heat engine operating between two thermal reservoirs can exceed the efficiency eta equals 1 Tc/Th, where Tc and Th are the absolute temperatures of the cold and hot reservoirs. This isn't a technological limitation. It's a fundamental wall that prevents perfect conversion of heat into work. Even idealized engines operating reversibly cannot breach this thermodynamic barrier, ensuring that some energy must always be rejected as waste heat. Maxwell's demon, the hypothetical intelligent agent that could sort fast and slow molecules to decrease entropy, initially seemed to challenge thermodynamic barriers. However, Rolf Landauer's insight revealed that the demon's computational operations require energy expenditure and generate entropy, maintaining the overall barriers created by the second law. Information processing itself has thermodynamic costs that create invisible walls, preventing violation of entropy increase principles. Statistical mechanics, developed by Ludwig Boltzmann and J. Willard Gibbs, reveals the microscopic origin of thermodynamic barriers. Entropy is proportional to the logarithm of the number of possible microscopic configurations, S equals k ln omega. Systems evolve toward states with more possible configurations, simply because these states are overwhelmingly more probable. The invisible barriers arise from pure statistics, the astronomical improbability of spontaneous transitions to lower entropy configurations. The Landauer limit establishes fundamental barriers to information processing efficiency. Erasure of one bit of information requires at least kT ln 2 joules of energy, where K is Boltzmann's constant and T is the absolute temperature. This creates invisible walls in computational systems that prevent perfect reversible computation and ensure that information processing always generates heat and entropy. Even quantum computers must respect these thermodynamic barriers when performing irreversible logical operations. Biological systems create the appearance of violating thermodynamic barriers by becoming more ordered and complex over time. However, Detailed analysis reveals that living organisms create invisible walls between local entropy decrease and global entropy increase. Biological processes decrease entropy locally while increasing entropy in their environment by even larger amounts, respecting thermodynamic barriers while creating complex structures and behaviors. The heat death scenario represents the ultimate thermodynamic barrier, a future state where the universe reaches maximum entropy and thermodynamic equilibrium. In this configuration, invisible walls would prevent any further net energy flow or useful work extraction. Stars would burn out, black holes would evaporate through Hawking radiation, and the universe would reach a state of maximum entropy where no further evolution or complexity generation would be possible. Quantum thermodynamics reveals how thermodynamic barriers extend into quantum mechanical systems. Quantum heat engines and refrigerators face fundamental limits similar to classical systems, but modified by quantum coherence and entanglement effects. The quantum Carnot cycle establishes barriers to efficiency in quantum thermal machines, while quantum error correction creates thermodynamic costs for maintaining quantum information against decoherence. The fluctuation dissipation theorem describes how thermal fluctuations create barriers to precise control of system properties. Random thermal motion ensures that no macroscopic system can maintain perfect order or complete control over its microscopic degrees of freedom. These invisible barriers manifest as Johnson noise in electrical circuits, Brownian motion in suspended particles, and thermal broadening in spectroscopic measurements. Irreversibility creates temporal barriers that prevent perfect restoration of past configurations. While fundamental physics equations are time reversible, thermodynamic processes create statistical barriers that make time reversal practically impossible. The probability of spontaneous unmixing of gases, spontaneous heating of cold objects, or spontaneous assembly of broken structures becomes vanishingly small for macroscopic systems, creating invisible walls that define the arrow of time. The third law of thermodynamics establishes absolute barriers to reaching zero temperature. Entropy approaches a constant minimum value as temperature approaches absolute zero. But perfect cooling remains impossible due to fundamental quantum mechanical and statistical barriers. The unattainability of absolute zero creates invisible walls that prevent perfect energy extraction and perfect elimination of thermal motion from any physical system. Phase transitions create discontinuous barriers in thermodynamic systems where small changes in conditions produce dramatic changes in system properties. The invisible walls at critical points separate different phases of matter, creating barriers that must be crossed for transitions between solid, liquid, gas, and plasma states. These barriers involve latent heat requirements and configurational changes that create sharp boundaries in thermodynamic parameter space. The equipartition theorem reveals how thermal energy creates invisible barriers to perfect energy localization. In thermal equilibrium, energy becomes equally distributed among all available degrees of freedom, creating barriers to concentrating energy in specific modes or configurations. This statistical spreading ensures that thermal systems resist attempts to create perfect energy segregation or complete energy localization. Modern research in stochastic thermodynamics has revealed how fluctuations and rare events can temporarily violate traditional thermodynamic barriers. Through large deviation statistics, systems can spontaneously decrease entropy for brief periods, but these violations become exponentially rare for large systems or long time periods. The invisible barriers remain intact on average while allowing temporary statistical breaches. Nanotechnology and molecular machines operate near thermodynamic barriers where thermal fluctuations become comparable to system energies. DNA replication, protein folding, and cellular metabolism all function in regimes where thermodynamic walls create significant constraints on efficiency and precision. These biological and synthetic molecular systems demonstrate how life operates near fundamental thermodynamic limits. The arrow of time emerges from thermodynamic barriers through the process of decoherence and entropy increase. While fundamental physics equations are time-symmetric, the second law creates invisible walls that distinguish past from future to statistical irreversibility. Cosmological evolution, stellar evolution, and biological evolution all reflect the universal tendency for entropy increase that creates temporal barriers preventing perfect reversibility. Quantum error correction in quantum computers faces fundamental thermodynamic barriers when correcting errors in quantum information. The energy cost of error correction, the heat generated by classical control systems, and the thermodynamic cost of measurement all create invisible walls that constrain quantum computing efficiency. Even fault-tolerant quantum computers must operate within thermodynamic limits that prevent perfect error correction without energy expenditure. Black hole thermodynamics reveals how gravitational systems obey thermodynamic barriers through the Bekenstein-Hawking entropy formula, S equals A4G, relating black hole entropy to horizon area. Hawking radiation creates thermal barriers that cause black holes to evaporate while respecting conservation of energy and information. These gravitational thermodynamic barriers connect quantum mechanics, general relativity, and statistical mechanics in profound ways. As you consider these thermodynamic walls, recognize that they represent barriers to perfect efficiency, perfect reversibility, and perfect control over physical systems. Every process you've ever witnessed, from the cooling of your coffee to the evolution of stars, operates within constraints created by invisible thermodynamic barriers that ensure useful energy always degrades into waste heat and that perfect machines remain forever impossible. But thermodynamic limits are just one aspect of the invisible architecture that constrains existence. We must now explore how mathematical and logical barriers create additional walls that limit what can be computed, proved, or decided. Chapter 7. Computational Boundaries. There are problems in mathematics and computation that cannot be solved by any conceivable algorithm, no matter how much time or computational power you provide. These represent invisible walls in the landscape of knowledge, itself fundamental barriers that separate decidable questions from undecidable ones, computable functions from uncomputable ones, and provable theorems from statements that forever remain beyond mathematical proof. Alan Turing's 1936 analysis of computational limits revealed the most fundamental barrier in computer science, the halting problem. Given an arbitrary computer program and input, there exists no general algorithm that can determine whether the program will eventually halt or run forever. This isn't about current technological limitations. It is about the logical structure of computation, itself creating invisible walls that prevent certain types of analysis regardless of computational resources or algorithmic cleverness. The proof of the halting problem's undestability reveals how self-reference creates absolute barriers in logical systems. Turing showed that any hypothetical algorithm claiming to solve the halting problem could be used to construct a paradoxical program that halts if and only if the algorithm predicts it will unhalt. This logical contradiction proves that no such algorithm can exist, creating an invisible wall that separates computable from uncomputable functions. Gödel's incompleteness theorems, proven in 1931, established even more fundamental barriers in mathematical logic. Any sufficiently complex formal system that includes arithmetic must contain statements that are true but cannot be proved within the system itself. This creates invisible walls in mathematics where certain truths remain forever inaccessible to formal proof, no matter how sophisticated the axiom system or proof techniques become. The first incompleteness theorem demonstrates that mathematical systems powerful enough to express basic arithmetic must be either incomplete, containing unprovable truths, or inconsistent, containing contradictions. The second incompleteness theorem shows that such systems cannot prove their own consistency without becoming inconsistent. These results create fundamental barriers to mathematical certainty that ensure absolute mathematical knowledge remains impossible. Complexity theory reveals computational barriers through problems like P versus NP, one of the most important unsolved questions in mathematics. While P problems can be solved efficiently, NP problems can only be verified efficiently, but may require exponential time to solve. If P does not equal NP, as most computer scientists believe, then invisible walls separate easily verifiable problems from easily solvable ones, creating permanent barriers to efficient computation for vast classes of important problems. The traveling salesman problem exemplifies these computational walls. Finding the shortest route visiting all cities in a network appears to require checking exponentially many possibilities as the number of cities increases. Despite decades of research and powerful algorithmic techniques, no polynomial time solution has been found, suggesting invisible barriers that may forever prevent efficient solutions to this and thousands of similar NP-complete problems. Rice's theorem establishes invisible walls around semantic properties of computer programs. Any non-trivial property of program behavior, what the program computes, not how it's written, is undecidable. You cannot write an algorithm that determines whether an arbitrary program computes a specific function, whether it contains infinite loops, or whether it will produce particular outputs. These barriers make automated program analysis fundamentally impossible for semantic properties. The busy beaver problem demonstrates how computational barriers create walls between finite and infinite quantities. Kolmogorov complexity reveals invisible barriers to data compression and randomness analysis. The shortest possible description of a string represents its algorithmic information content, but this quantity is uncomputable in general. You cannot determine whether a given string is truly random or merely appears random due to limited analytical tools. This creates fundamental walls between apparent complexity and true algorithmic complexity. Church's thesis suggests that the class of effectively computable functions coincides with functions computable by Turing machines. But this thesis creates barriers to expanding computational power beyond current models. If Church's thesis is correct, then no physically realizable computational device, biological, quantum, or otherwise, can solve uncomputable problems like the halting problem. Physical computation faces the same logical walls that constrain abstract mathematical computation. Quantum computation might breach certain computational barriers while respecting others. Shor's algorithm demonstrates quantum speedup for factoring large numbers, potentially solving problems that are intractable for classical computers. However, quantum computers cannot solve undecidable problems like the halting problem, and the relationship between quantum complexity classes and classical ones remains unclear. Quantum mechanics may move some computational walls without eliminating them entirely. The frame problem in artificial intelligence reveals barriers to common-sense reasoning about change and causality. Determining which facts remain true after an action occurs seems to require checking potentially infinite implications, creating computational walls that have prevented the development of truly general-purpose reasoning systems. These barriers emerge from the logical structure of knowledge representation rather than processing speed limitations. Logical paradoxes create additional invisible barriers in formal systems. Russell's paradox, the liar paradox, and related self-referential constructions reveal fundamental walls in set theory, logic, and semantics. These paradoxes have driven the development of type theory, set theory axiomatizations, and other formal frameworks. But they continue to create barriers that prevent completely unrestricted logical reasoning systems. The constant problem in mathematics reveals barriers between symbolic and numerical computation. Determining whether expressions involving mathematical constants like pi, e, and algebraic numbers are zero appears to be undecidable in general. This creates invisible walls between mathematical expressions that seem similar but have fundamentally different computational properties regarding decidability and verification. Diophantine equations, polynomial equations with integer solutions, create computational barriers through Hilbert's 10th problem. Matyasiewicz proved that no algorithm can determine whether arbitrary Diophantine equations have integer solutions, connecting number theory to computational undestability. These barriers prevent automated solution of many fundamental questions in arithmetic and algebra. The word problem for groups demonstrates how algebraic structures create computational walls. Given a finite presentation of a group and two group elements, it's undecidable whether the elements are equivalent under the group operations. This barrier extends to many other algebraic structures, revealing fundamental limits to automated algebraic reasoning and symbolic computation. Chaitin's constant, the probability that a random program halts, represents an uncomputable real number that encodes solutions to infinitely many mathematical problems. While this constant is well defined mathematically, it cannot be computed algorithmically, creating invisible barriers between mathematical existence and computational accessibility. Knowledge of Chaitin's constant would solve numerous undecidable problems, but the constant itself remains forever beyond computational reach. The Collatz conjecture and similar problems reveal potential barriers in number theory, where simple-to-state problems resist both proof and algorithmic solution. Whether these represent fundamental undecidable problems or merely difficult decidable ones remains unknown, illustrating how computational barriers can hide behind apparently elementary mathematical questions. Machine learning faces computational barriers through the no-free lunch theorem, which proves that no learning algorithm performs better than random guessing across all possible problem domains. This creates invisible walls that prevent the development of universally optimal learning systems and ensure that all artificial intelligence must be specialized to particular problem classes rather than achieving general-purpose reasoning capability. Complexity theory reveals barriers through problems like graph isomorphism, integer factorization, and discrete logarithm computation that appear to be neither NP nor NP complete. These intermediate problems create invisible walls in the computational landscape that separate different levels of difficulty and suggest that computational complexity may have more subtle structure than simple P versus NP classification. As you contemplate these computational walls, recognize that they represent barriers to knowledge and problem-solving that transcend technological limitations. These invisible boundaries are built into the logical structure of mathematics and computation itself, ensuring that certain questions will forever remain beyond algorithmic solution and that perfect knowledge through computation remains impossible regardless of future technological development. But computational boundaries are just one layer of the invisible architecture that constrains existence. We must now explore how consciousness itself may face fundamental barriers that limit self-understanding and complete introspection. Chapter 8. Consciousness Barriers. The phenomenon of consciousness appears to encounter invisible walls that prevent complete self-understanding, creating barriers between subjective experience and objective analysis that may be fundamentally unbridgeable. These aren't temporary limitations waiting for better neuroscience. They're potential structural barriers built into the relationship between minds and reality that ensure certain aspects of consciousness remain forever beyond complete comprehension. The hard problem of consciousness, articulated by philosopher David Chalmers, reveals the most fundamental barrier in understanding subjective experience. While neuroscience can explain many cognitive functions, memory, attention, sensory processing, motor control, it faces an invisible wall when attempting to explain why there is something it feels like to be conscious. The qualitative, subjective nature of experience seems separated by an explanatory gap from objective physical processes. Consider your direct awareness of reading these words right now. This subjective experience possesses qualities: the visual appearance of text, the sense of understanding meaning, the feeling of focused attention, that seem categorically different from neural firing patterns, neurotransmitter concentrations, or electromagnetic field fluctuations in your brain. The invisible wall between subjective experience and objective description has resisted centuries of philosophical analysis and decades of neuroscientific investigation. The binding problem in neuroscience reveals additional barriers to understanding conscious integration. Your brain processes visual information about color, motion, shape, and depth in separate neural regions. Yet you experience a unified visual field rather than disconnected fragments. How distributed neural processing creates unified conscious experience remains mysterious, with potential barriers preventing complete understanding of consciousness integration mechanisms. Thomas Nagel's analysis of consciousness barriers, through his famous question, "What is it like to be a bat?" demonstrates how subjective experience creates invisible walls between different types of conscious awareness. Bat echolocation involves sensory experiences that humans cannot directly access or fully imagine. This suggests fundamental barriers to complete intersubjective understanding that may prevent any conscious being from fully comprehending all forms of conscious experience. The frame problem of consciousness creates barriers to understanding how minds maintain coherent beliefs and experiences despite constantly changing sensory input. Your conscious experience maintains continuity and relevance despite receiving overwhelming amounts of new information every moment. How consciousness selects, integrates, and maintains coherent experience while filtering irrelevant information involves cognitive barriers that remain largely mysterious. Introspection itself faces invisible walls that prevent complete self-knowledge. When you attempt to examine your own thought processes, the act of introspection changes the very processes being examined. This creates observer effects in consciousness that may establish fundamental barriers to complete self-understanding. The mind cannot step outside itself to observe its own operations from an external perspective. The symbol grounding problem reveals barriers between conscious understanding and computational processing. While computers can manipulate symbols according to rules, consciousness involves understanding meaning in ways that seem to transcend symbol manipulation. How neural processes give rise to semantic understanding rather than mere syntactic symbol processing remains separated by invisible walls from current computational theories of mind. Qualia the subjective, experiential qualities of conscious states appear to exist behind barriers that prevent objective scientific analysis. The redness of red, the painfulness of pain, the taste of chocolate, these experiential qualities seem irreducible to physical descriptions. Even complete knowledge of neural processes associated with these experiences may not bridge the invisible wall between objective description and subjective reality. The combination problem for consciousness creates barriers to understanding how individual neural processes combine into unified conscious experience. If consciousness emerges from neural activity, how do billions of separate neural events create singular, unified awareness? This combinatorial barrier has puzzled philosophers and scientists attempting to understand how microscopic processes generate macroscopic conscious experience. Free will encounters potential barriers through the relationship between conscious decision-making and deterministic physical processes. Benjamin Libet's experiments revealed that brain activity associated with decisions begins several hundred milliseconds before conscious awareness of those decisions creating questions about whether consciousness faces barriers that prevent it from being the true initiator of actions. The explanatory gap between neural processes and conscious experience may represent a fundamental barrier rather than a temporary knowledge limitation. Even complete mapping of neural connectivity and complete understanding of brain function might not bridge the invisible wall between objective brain states and subjective conscious states. This gap has led some philosophers to argue that consciousness involves non-physical properties that create permanent barriers to scientific understanding. Phenomenology reveals barriers to completely objective analysis of consciousness by emphasizing the irreducibly subjective nature of conscious experience. Edmund Husserl and Maurice Merleau-Ponty argued that consciousness cannot be fully understood from a purely objective scientific perspective because objectivity itself is a product of conscious experience. This creates circular barriers where consciousness must be used to study consciousness. The unity of consciousness creates barriers to understanding how diverse neural processes create singular experiential streams. Your current conscious experience integrates visual perception, auditory input, tactile sensations, emotional states, memory recall, and active thinking into a unified stream of awareness. How this integration occurs across different brain regions and timescales involves barriers that resist current neuroscientific explanation. Altered states of consciousness reveal additional barriers to understanding the relationship between brain states and conscious experience. Meditation, psychedelic experiences, anesthesia, and sleep create dramatically different conscious states that don't map simply onto neural changes. These state-dependent barriers suggest that the relationship between consciousness and brain activity may be more complex than simple correlation or causation. The boundary problem of consciousness creates invisible walls around questions of which systems are conscious and which are not. Does consciousness require biological neural networks, or could artificial systems achieve consciousness? Are non-human animals conscious, and if so, which ones? These boundary questions face barriers that may prevent definitive answers through purely objective methods. Integrated information theory, developed by Giulio Tononi, attempts to bridge consciousness barriers by proposing that consciousness corresponds to integrated information, phi, in physical systems. However, calculating integrated information faces computational barriers that prevent practical application to complex systems like human brains. The theory creates new invisible walls, even as it attempts to bridge others. The Chinese room argument, proposed by John Searle, reveals barriers between syntactic processing and semantic understanding. A system could potentially pass behavioral tests for consciousness while lacking genuine understanding or experience. This creates invisible walls that prevent purely behavioral criteria from definitively establishing the presence or absence of consciousness in any system. Panpsychist theory suggests that consciousness faces barriers because it's been incorrectly assumed to emerge from unconscious matter. If consciousness is fundamental rather than emergent, then the hard problem dissolves. But new barriers emerge around, explaining how simple conscious entities combine into complex conscious experiences without losing their essential conscious properties. The measurement problem in quantum mechanics creates potential barriers connecting consciousness to physical reality. Some interpretations suggest that consciousness plays a special role in collapsing quantum wave functions, creating invisible walls between conscious observation and physical reality. However, these connections remain highly speculative and face their own theoretical barriers. Global workspace theory proposes that consciousness arises from global information integration across brain networks, but faces barriers in explaining why global integration should produce subjective experience rather than merely complex information processing. The theory addresses functional aspects of consciousness while potentially leaving qualitative aspects behind invisible explanatory walls. Neural correlates of consciousness research attempts to map brain activity patterns associated with conscious states, but faces barriers in distinguishing correlation from causation. Finding neural correlates doesn't necessarily explain how neural activity generates conscious experience, potentially leaving the fundamental consciousness barriers intact, even with complete neural mapping. Artificial consciousness research encounters barriers in determining whether computational systems could achieve genuine consciousness, rather than merely simulating conscious behavior. These barriers involve both technical challenges in creating sufficiently complex computational systems and conceptual challenges in defining and recognizing artificial consciousness. The recursion barrier in consciousness involves the infinite regress problem of consciousness being aware of its own awareness. If consciousness involves self-awareness, then what is aware of that self-awareness? This creates potential infinite recursion that may represent a fundamental barrier to complete conscious self-understanding. As you contemplate these consciousness barriers, recognize that they may represent the ultimate invisible walls barriers, not just between different regions of physical reality, but between mind and reality itself. These walls ensure that consciousness remains partially mysterious to itself, creating boundaries around self-knowledge that may be inherent to the nature of conscious experience rather than temporary limitations of current understanding. But consciousness barriers are just one aspect of the invisible architecture that constrains existence. We must now explore how these various invisible walls combine to create nested layers of cosmic imprisonment. Chapter 9. Nested Prisons. The invisible walls we've explored don't exist in isolation. They form a complex architecture of nested barriers, each layer of constraint embedded within larger systems of limitation, creating a hierarchical structure of cosmic imprisonment where escape from one level of confinement only reveals deeper, more fundamental walls that constrain existence at every scale. Almora, fundamental walls that constrain existence at every scale. Consider your current situation as you read these words. You're simultaneously imprisoned within multiple nested invisible barriers operating at different scales and through different physical mechanisms. At the quantum level, uncertainty principles prevent perfect knowledge of your constituent particles' properties. These quantum walls exist within atomic structures, bound by electromagnetic forces that create chemical prisons, determining which molecular configurations are stable and which are forbidden. Your biological cells operate within thermodynamic walls that constrain energy conversion efficiency and create irreversible entropy production. These thermodynamic barriers exist within gravitational wells that trap you on Earth's surface, embedded within the Sun's much larger gravitational prison, which is itself confined within the Milky Way galaxy's vast gravitational architecture. Each level of imprisonment operates through different physics, but combines to create overlapping constraint systems. The speed of light creates causal barriers that separate you from distant events, but these light-speed walls are embedded within cosmological expansion that creates moving boundaries continuously shrinking the realm of possible future contact. The expanding universe contains event horizons nested within particle horizons, creating multiple overlapping invisible barriers that define different types of causal isolation at cosmic scales. Information processing faces computational walls through undescribability and complexity barriers, but these abstract limitations are implemented through physical systems that must respect thermodynamic limits on energy conversion, quantum mechanical limits on measurement precision, and relativistic limits on information transmission speed. Mathematical impossibility becomes physically enforced through nested layers of constraint operating simultaneously. Consciousness encounters barriers to complete self-understanding, but conscious experience requires neural processes that operate within biological constraints, which function according to chemical reaction limitations. which depend on electromagnetic interactions that respect quantum mechanical rules. The invisible walls around consciousness exist within and depend upon multiple layers of more fundamental physical constraints. The Earth's atmosphere creates chemical barriers that prevent certain molecular configurations while existing within gravitational barriers that prevent atmospheric escape. These atmospheric constraints enable biological barriers that limit which evolutionary pathways are possible, creating nested chemical gravitational biological prison systems that determine the boundaries of terrestrial life. Stellar evolution operates within nuclear physics barriers that determine which fusion reactions are possible at different temperature and pressure conditions. But stars themselves exist within gravitational wells that constrain their formation and evolution patterns. The nuclear barriers are nested within gravitational barriers, creating hierarchical constraints on stellar life cycles and the synthesis of heavy elements necessary for planetary systems. Galaxy formation faces barriers from dark matter distribution patterns that create gravitational constraints on structure formation. But these constraints operate within cosmological expansion barriers that limit the time available for gravitational collapse and structure formation. The invisible walls of cosmic structure formation involve nested gravitational, temporal, and thermodynamic constraints operating across vastly different scales. Quantum field theory reveals how particle physics barriers emerge from symmetry constraints and conservation laws. But these symmetry walls exist within spacetime curvature created by gravitational fields. The standard model of particle physics operates within the curved spacetime geometry described by general relativity, creating nested quantum gravitational constraint systems that define fundamental interaction possibilities. Biological evolution encounters barriers through genetic constraints on mutation possibilities. But these molecular barriers exist within environmental constraints that determine which genetic variations provide survival advantages. The invisible walls of evolutionary possibility involve nested genetic environmental temporal barriers that determine the pathways available for biological complexity development. Technological development faces engineering barriers limited by materials science constraints. But these materials constraints operate according to atomic and molecular physics that must respect quantum mechanical and thermodynamic limitations. The invisible walls preventing certain technologies involve nested engineering physics mathematical barriers that create hierarchical impossibilities, extending from practical to fundamental levels. Economic systems encounter barriers through resource limitations and coordination problems. But these economic constraints operate within physical systems that must respect conservation laws and thermodynamic efficiency limits. The invisible walls of economic possibility are nested within resource walls, which are embedded within physical constraint systems that define ultimate productivity boundaries. Communication faces barriers through channel capacity limitations and noise constraints. But these information theoretic walls operate within physical transmission systems that must respect electromagnetic propagation, limits, and quantum mechanical measurement uncertainties. The invisible barriers to perfect communication involve nested information physical quantum constraint systems. Social organization encounters barriers through coordination problems and collective action difficulties. But these social walls emerge from individual cognitive limitations that arise from neural processing, constraints operating according to biological and physical laws. The invisible barriers to perfect social coordination involve nested cognitive, biological, physical constraint hierarchies. Climate systems face barriers through energy balance constraints and feedback loop limitations. But these thermodynamic walls operate within planetary systems that exist within stellar energy output constraints and astronomical orbital dynamics. The invisible barriers governing climate evolution involve nested thermodynamic gravitational astronomical constraint systems. Computational systems encounter barriers through complexity limitations and undestability problems. But these mathematical walls are implemented through physical computing systems that must respect thermodynamic energy conversion limits and quantum mechanical measurement constraints. The invisible barriers to perfect computation involve nested logical thermodynamic quantum constraint hierarchies. The nested structure of invisible walls creates emergent properties where constraint systems at different levels interact to produce barriers that are more restrictive than any individual constraint system alone. Quantum uncertainty combines with thermodynamic irreversibility to create information processing limitations that are more severe than either quantum or thermodynamic walls would create independently. Gravitational barriers combine with cosmological expansion to create causal isolation effects that are more absolute than either gravitational or expansion barriers alone would produce. The nested constraint systems create interference effects where multiple types of invisible walls reinforce each other to produce stronger overall imprisonment than simple addition of individual barriers would suggest. The hierarchy of nested prisons creates apparent escape routes that lead only to high-level constraints. Quantum tunneling allows particles to penetrate classical energy barriers, but the tunneling probabilities are governed by quantum mechanical laws that create their own statistical barriers. Gravitational slingshot maneuvers allow spacecraft to gain energy by exploiting planetary motion, but the available energy gains are limited by orbital mechanics constraints that operate within larger gravitational prison systems. Revolutionary breakthroughs in one domain of constraint typically reveal previously unknown barrier systems at deeper levels. The development of quantum mechanics resolved certain classical physics paradoxes while revealing new invisible walls around measurement, uncertainty, and quantum classical transitions. General relativity resolved inconsistencies between special relativity and gravitation while revealing new barriers around black hole horizons and cosmological boundaries. The nested architecture suggests that complete escape from invisible walls may be impossible in principle rather than merely difficult in practice. Each level of constraint appears to be embedded within more fundamental constraint systems, creating recursive imprisonment where breaking through one barrier only reveals the existence of deeper, more absolute walls that define the ultimate boundaries of possible existence. As you contemplate this hierarchical architecture of invisible barriers, recognize that you exist within multiple simultaneous constraint systems that operate at every scale from quantum to cosmic. The nested prisons ensure that no local escape from limitation is possible without confronting more global barriers that define the fundamental structure of reality itself. But understanding the nested architecture of invisible walls is just preparation for exploring their ultimate implications. We must now confront what this cosmic imprisonment means for the possibilities and limitations of existence itself. Chapter 10. Escape attempts throughout history. Conscious beings have attempted to breach the invisible walls that constrain existence, developing technologies, theories, and strategies designed to transcend the barriers that limit possibility. But every apparent escape route from cosmic imprisonment has revealed new, more fundamental walls that demonstrate the persistent nature of constraint systems and the hierarchical structure of invisible barriers. Ancient civilizations attempted to escape gravitational imprisonment through architecture and mythology, building pyramids and towers that reached toward the heavens while developing cosmologies that promised liberation from terrestrial limitations. The Tower of Babel represents humanity's earliest symbolic attempt to breach the invisible walls between earth and sky, between human limitation and cosmic transcendence. But gravitational barriers remained intact, and the mythological escape routes led only to deeper questions about the nature of cosmic constraint. The development of flight technology represented humanity's first successful breach of immediate gravitational barriers. But this apparent escape from Earth's surface only revealed the broader architecture of atmospheric, orbital, and interplanetary constraint systems. Aviation overcome local gravitational walls while confronting aerodynamic barriers, propulsion limitations, and the vast energy requirements needed to achieve orbital velocity. Each breakthrough revealed new invisible boundaries. Rocket technology and space exploration represent more ambitious attempts to escape gravitational imprisonment, with missions like Voyager 1 and 2 actually breaching the heliosphere boundary and entering interstellar space. But these escapes from solar system confinement only emphasize the vast scales of galactic and intergalactic barriers that create larger prison systems. The spacecraft carry messages to potential alien civilizations, but they remain trapped within light-speed communication barriers and cosmic expansion boundaries. Quantum mechanics initially appeared to offer escape routes from classical deterministic barriers through principles like quantum tunneling, superposition, and entanglement. Quantum tunneling allows particles to penetrate energy barriers that are classically insurmountable, while quantum superposition seems to permit systems to exist in multiple states simultaneously. However, detailed analysis revealed the quantum escape mechanisms operate within their own invisible walls defined by probability amplitudes, measurement constraints, and decoherence effects. Quantum computing represents an attempt to breach classical computational barriers by exploiting quantum superposition and entanglement to perform parallel computations across multiple quantum states. Algorithms like Shor's factoring algorithm and Grover's search algorithm demonstrate quantum speedups that appear to transcend classical complexity barriers. However, quantum computers cannot solve undecidable problems like the halting problem, and they face new barriers through quantum error rates, decoherence times, and the measurement problem. Theoretical physics has proposed various escape mechanisms from fundamental constraint systems through concepts like wormholes, extra dimensions, and modified gravity theories. Wormholes would theoretically allow faster-than-light travel by creating shortcuts through curved spacetime geometry. Extra-dimensional theories suggest that apparent barriers in three-dimensional space might be circumvented through motion in higher dimensions. However, these theoretical escape routes face their own constraint barriers through exotic matter requirements, energy conditions, and stability problems. The many-worlds interpretation of quantum mechanics proposes escape from measurement collapse barriers by suggesting that all possible quantum outcomes occur in parallel universes. This would theoretically allow consciousness to experience all possible futures simultaneously, transcending the constraints created by quantum measurement. However, the many-worlds escape route creates new barriers around interworld communication and the selection of experienced reality branches. Artificial intelligence development represents an attempt to escape biological cognitive barriers through computational enhancement of intelligence capabilities. Advanced AI systems could potentially transcend human limitations in memory, processing speed, pattern recognition, and logical reasoning. However, AI systems face their own invisible walls through computational complexity barriers, the frame problem, consciousness boundaries, and the fundamental limits of formal systems revealed by Gödel's incompleteness theorems. Genetic engineering and biotechnology offer potential escape routes from biological constraint systems through modification of evolutionary limitations, enhancement of human capabilities, and extension of lifespan boundaries. CRISPR gene editing, synthetic biology, and regenerative medicine might allow conscious beings to transcend inherited genetic barriers and biological aging processes. However, these biological escape attempts encounter new walls through ecological constraints, evolutionary trade-offs, and the complexity barriers of biological systems. Nanotechnology proposes escape from material science limitations through molecular-scale manufacturing and engineering. Molecular assemblers could theoretically construct any physically possible structure, atom by atom, transcending traditional manufacturing constraints and resource limitations. However, nanotechnology faces invisible barriers through thermodynamic costs of molecular manipulation, quantum effects at small scales, and the complexity of molecular machine design. Virtual and augmented reality technologies offer escape routes from physical world constraints by creating artificial sensory environments that transcend geographical, physical, and even physical law limitations. Immersive virtual worlds could allow conscious experience to operate within entirely different constraint systems with modified physics, alternative geometries, and enhanced capabilities. However, virtual escape routes ultimately depend on physical computational substrates that must respect thermodynamic, quantum, and relativistic barriers. Cryonic preservation represents an attempt to escape temporal barriers and biological decay through ultra-low temperature preservation followed by future revival using advanced medical technologies. This would theoretically allow conscious beings to transcend the temporal limitations of single lifespans and benefit from future technological breakthroughs. However, cryonic escape attempts face barriers through cellular damage during freezing, information preservation requirements, and uncertainty about future revival capabilities. Transhumanist philosophies propose systematic escape from human limitation barriers through technological enhancement of biological, cognitive, and sensory capabilities. Brain-computer interfaces, genetic modification, life extension technologies, and consciousness uploading could theoretically allow conscious beings to transcend the constraints that define human existence. However, transhumanist escape routes encounter new barriers around personal identity, consciousness transfer, and the relationship between minds and computational substrates. Upload scenarios suggest the ultimate escape from biological barriers through transfer of conscious experience to computational substrates that could operate at enhanced speeds with improved memory systems and potentially indefinite operational lifespans. Consciousness uploading would represent escape from biological aging, genetic limitations, and evolutionary constraint systems. However, upload escape routes face fundamental barriers around consciousness, computational limits, and the hard problem of subjective experience. Faster-than-light travel proposals, including Alcubierre warp drives, traversable wormholes, and tachyonic communication systems, represent attempts to escape relativistic barriers that prevent rapid interstellar travel and communication. These proposals would theoretically allow conscious civilizations to escape from light speed imprisoned within individual star systems. However, faster-than-light escape mechanisms require exotic matter with negative energy densities, violate causality constraints, or face stability problems that create their own invisible walls. Mathematical and logical escape attempts through non-classical logic systems, alternative set theories, and revised foundations of mathematics represent efforts to transcend the barriers revealed by Gödel's incompleteness theorems and other formal limitations. These approaches might theoretically escape from traditional logical constraints while maintaining mathematical rigor and consistency. However, alternative logical systems face their own invisible barriers through expressiveness limitations, semantic paradoxes, and the relationship between formal systems and physical reality. Each attempted escape from invisible walls reveals a deeper truth about the architecture of constraint systems. Barriers appear to be fundamental features of reality, rather than temporary limitations waiting for technological solutions. The nested structure of invisible walls ensures that breakthrough of one barrier typically reveals previously unknown constraint systems operating at more fundamental levels. The pattern of failed escape attempts suggests that complete liberation from invisible walls may be impossible in principle rather than merely difficult in practice. Every successful transcendence of local barriers has revealed global constraints that define larger prison systems. Every technological breakthrough has uncovered new technological barriers. Every theoretical advance has exposed new theoretical limitations. As you contemplate these systematic failures to achieve complete escape from invisible walls, recognize that they point toward a profound conclusion about the nature of existence itself. The persistent failure of escape attempts, despite centuries of technological and theoretical progress, suggests that constraint systems may be essential features of reality rather than accidental obstacles to unlimited possibility. But understanding the futility of escape attempts is preparation for the deepest question of all. What does cosmic imprisonment mean for consciousness, meaning, and the ultimate nature of existence within invisible walls? Chapter 11. Prison Philosophy. If we are truly surrounded by invisible walls we cannot cross, if every attempt at escape only reveals deeper layers of constraint, if the universe itself is fundamentally a nested hierarchy of prisons, then what does this mean for consciousness, free will, meaning, and the ultimate nature of existence? The recognition of cosmic imprisonment forces us to confront the most profound questions about reality and our place within its invisible architecture. The philosophical implications of universal constraint systems challenge traditional concepts of freedom and possibility. If quantum uncertainty prevents perfect knowledge, if thermodynamic barriers ensure irreversible processes, if computational limits create undecidable problems, and if cosmological boundaries separate causally disconnected regions, then the universe appears to be constructed from fundamental limitations rather than unlimited potential. This raises disturbing questions about whether true freedom is possible or merely an illusion created by insufficient awareness of invisible barriers. Existentialist philosophy gains new significance when viewed through the lens of cosmic imprisonment. Jean-Paul Sartre's declaration that existence precedes essence takes on deeper meaning if conscious beings find themselves thrown into a reality structured by invisible walls that constrain possible development pathways. The freedom to create meaning and identity operates within geometric, thermodynamic, and logical boundaries that define what kinds of existence are possible and which remain forever forbidden. The concept of free will encounters perhaps its ultimate challenge through invisible barrier analysis. If your thoughts arise from neural processes constrained by quantum uncertainty, if your decisions emerge from computational systems limited by undestability problems, if your actions operate within gravitational wells and thermodynamic irreversibility requirements, then what remains of autonomous choice? The walls surrounding consciousness may be so fundamental that conscious agency itself becomes a local phenomenon operating within global constraint systems. Buddhist philosophy's emphasis on the universality of suffering and limitation resonates with cosmic imprisonment concepts. The Four Noble Truths describe existence as fundamentally characterized by suffering, impermanence, and constraint. If invisible walls are indeed fundamental features of reality rather than temporary obstacles, then Buddhist insights about accepting limitation and finding peace within constraint may offer profound wisdom about navigating cosmic imprisonment. Stoic philosophy provides another framework for understanding existence within invisible boundaries. Marcus Aurelius, Epictetus, and other Stoic thinkers emphasize the distinction between what is under our control and what lies beyond human influence. If cosmic invisible walls represent the ultimate expression of what lies beyond control, then Stoic practices of focusing attention on immediate, local possibilities while accepting larger constraint systems may offer practical wisdom for conscious beings trapped within nested prison architectures. The concept of dignity gains new complexity when considered within cosmic imprisonment frameworks. Human dignity traditionally depends on ideas about rational agency, moral responsibility, and the capacity for self-determination. If invisible walls constrain these capacities at fundamental levels, then dignity must be redefined to acknowledge both the reality of constraint and the authentic possibilities that remain available within barriers. Dignity becomes not escape from limitation, but conscious engagement with constraint. Meaning and purpose face existential challenges through invisible wall recognition. If conscious beings cannot escape from nested constraint systems, if technological progress only reveals deeper barriers, if the universe itself prevents unlimited development, then traditional concepts of progress, achievement, and transcendence require fundamental revision. Meaning must be discovered within limitation rather than through escape from limitation. The relationship between individual and cosmic scales takes on new significance with imprisoned philosophy. Your personal constraints, genetic inheritance, cultural conditioning, cognitive limitations, finite lifespan operate within larger constraint systems that extend to quantum mechanical, thermodynamic, gravitational, and cosmological scales. Personal growth and self-actualization must occur within hierarchical barrier systems that ensure complete liberation remains impossible. Ethical frameworks require revision when fundamental constraints on possibility are acknowledged. If invisible walls prevent certain outcomes regardless of intention or effort, then moral responsibility must be calibrated to acknowledge both individual agency within local constraint systems and the reality of global barriers that limit achievable outcomes. Ethics becomes the art of navigating constraint systems while maintaining authentic choice within limited possibility spaces. The concept of hope transforms within cosmic imprisonment recognition. Traditional hope often involves expectation that future developments will transcend current limitations and achieve previously impossible outcomes. But if invisible walls represent fundamental rather than temporary barriers, then hope must be recalibrated to focus on authentic possibilities within constraint systems rather than impossible escape from all limitation. Hope becomes local rather than cosmic, focused on genuine rather than imaginary possibilities. Aesthetic experience gains heightened significance within invisible barrier frameworks. If consciousness is imprisoned within nested constraint systems, then beauty, art, and aesthetic contemplation may represent some of the most profound forms of transcendence available within cosmic limitations. Aesthetic experience allows consciousness to explore possibility spaces within barriers, creating meaning through creative engagement with constraint rather than escape from constraint. The relationship between knowledge and reality encounters fundamental challenges through invisible wall recognition. If quantum mechanics prevents perfect measurement, if consciousness cannot fully understand itself, if computational systems face undecidable problems, then complete knowledge remains impossible regardless of investigative sophistication. Epistemology becomes the study of knowledge acquisition within fundamental knowledge barriers rather than the pursuit of unlimited understanding. Scientific practice requires philosophical revision within cosmic imprisonment frameworks. Science traditionally aims toward ever-expanding knowledge and ever-increasing technological capability. But if invisible walls create absolute barriers to certain types of knowledge and technological achievement, then scientific progress must be understood as exploration within constraint systems rather than elimination of all constraint. Scientific discovery maps the architecture of invisible walls rather than transcending all barriers. Religious and spiritual traditions gain new relevance through invisible barrier recognition. Many spiritual teachings emphasize acceptance of limitation, surrender to larger forces, and finding peace within constraint rather than through transcendence of all limitation. If cosmic imprisonment is fundamental, then spiritual wisdom about navigating limitation may offer more practical guidance than technological approaches that attempt barrier elimination. The concept of authenticity becomes crucial within prison philosophy. If escape from all invisible walls is impossible, then authentic existence must involve honest recognition of constraint systems combined with creative engagement with available possibilities within barriers. Authenticity requires neither denial of limitation nor despair about constraint. but rather conscious choice about how to engage with the reality of cosmic imprisonment. Interpersonal relationships take on heightened significance within invisible barrier frameworks. If individual consciousness is imprisoned within multiple constraint systems, then connections between conscious beings represent some of the most profound transcendence available within cosmic limitation. Love, friendship, and community create local meaning systems that operate within global constraint architectures. The question of ultimate purpose gains new depth through cosmic imprisonment recognition. If the universe itself is structured by invisible walls that prevent unlimited development, then purpose cannot be located in eventual transcendence of all limitation. Instead, purpose must be found in the quality of engagement with constraint systems, in the creativity expressed within barriers, in the consciousness developed within limitation, and in the meaning created within impossible circumstances. As you contemplate your existence within invisible walls, recognize that cosmic imprisonment may not represent a tragedy to be mourned, but a fundamental condition to be understood and creatively engaged. The barriers that surround consciousness at every scale, from quantum uncertainty to cosmological horizons, define the landscape within which authentic existence unfolds. They create the boundaries that give shape to possibility, the constraints that make choice meaningful, and the limitations that ensure conscious experience retains mystery and wonder. The invisible walls we cannot cross may be not obstacles to authentic existence, but the very architecture that makes authentic existence possible. Within cosmic prison systems, consciousness finds itself not condemned to meaninglessness, but invited to discover meaning within constraint, purpose within limitation, and transcendence within imprisonment. Throughout this journey into the invisible architecture of cosmic imprisonment, we've discovered that reality itself is constructed from barriers, quantum walls that prevent perfect knowledge, gravitational wells that create geometric prisons, light-speed barriers that separate causally connected from causally disconnected events, thermodynamic limits that ensure irreversible energy degradation, computational boundaries that place absolute restrictions on knowledge acquisition, consciousness barriers that prevent complete self-understanding, cosmological horizons that forever separate accessible from inaccessible regions of the universe. But perhaps the most profound realization is this: these invisible walls are not obstacles preventing us from reaching our true destination. They are the destination. The barriers that surround existence at every scale don't separate us from reality. They constitute reality itself. The universe is not a place where consciousness happens to be temporarily imprisoned until some future escape becomes possible. The universe is a prison architecture, and consciousness is what happens when matter becomes complex enough to experience imprisonment from the inside. Consider the extraordinary nature of your current situation. You are a pattern of organized complexity that has emerged within multiple nested constraint systems, a configuration of matter and energy that has become sophisticated enough to recognize its own limitations. You exist as an island of structured information within thermodynamic systems that tend toward maximum entropy, as a quantum mechanical system that maintains classical behavior despite fundamental uncertainty, as a conscious observer embedded within the very space-time geometry that constrains your possible futures. The walls we've explored, from Heisenberg uncertainty to cosmological event horizons, create the landscape within which authentic existence unfolds. Without quantum barriers, perfect prediction would eliminate novelty and surprise. Without thermodynamic limits, perfect energy conversion would remove the arrow of time that gives meaning to choice and development. Without gravitational wells, matter would never aggregate into the complex structures that make consciousness possible. Without light-speed barriers, causality would collapse and coherent experience would become impossible. As you go about your life after learning about cosmic imprisonment, remember that every conscious moment occurs within this invisible architecture. When you make decisions, you're navigating possibility spaces carved out by invisible walls. When you form relationships, you're creating local meaning systems within global constraint hierarchies. When you pursue knowledge, you're mapping the barriers that define what can be known and what must remain mysterious. When you create art or experience beauty, you're finding transcendence within limitation rather than escape from all constraint. The recognition of invisible walls transforms rather than diminishes the significance of conscious existence. Your thoughts, experiences, relationships, and creative expressions gain heightened meaning precisely because they occur within fundamental limitations. The barriers don't prevent authentic existence, they provide the framework within which authentic existence becomes possible. A universe without invisible walls would be a universe without shape, without boundaries that create the possibility of inside and outside, without constraints that make choice meaningful. You are not separate from the cosmic prison systems we've explored. You are not a free agent accidentally trapped within invisible barriers. You are consciousness that has emerged from the interaction of constraint systems, awareness that is developed within limitation, a pattern of organized complexity that represents the universe becoming conscious of its own prison architecture from the inside. The quantum uncertainty that prevents perfect knowledge about your constituent particles is the same uncertainty that allows novelty and surprise in your conscious experience. The thermodynamic barriers that ensure entropy increase in your cellular processes are the same. Barriers that create the arrow of time within which your experiences unfold. The gravitational wells that trap you on Earth's surface are the same geometric curvature that holds together the planetary system that makes your biological existence possible. The lightspeed barriers that prevent instantaneous communication across cosmic distances are the same barriers that create stable causal structure within which coherent thought and experience can develop. The computational limits that prevent algorithmic solutions to all problems are the same limits that ensure certain questions remain genuinely open for conscious exploration. The consciousness barriers that prevent complete self-understanding are the same barriers that preserve the mystery and wonder that make conscious existence meaningful rather than mechanical. In this final moment of our exploration, recognize that you have spent these past minutes engaged in one of the most extraordinary activities possible within cosmic prison systems. Consciousness understanding its own constraints, awareness mapping its own limitations, intelligence exploring the invisible architecture within which it exists. This understanding itself represents a form of transcendence available within cosmic imprisonment, not escape from barriers, but conscious recognition of the barrier systems that define the landscape of possibility. The invisible walls we cannot cross are not failures of cosmic engineering. They are achievements of cosmic architecture, creating the bounded possibility spaces within which consciousness can emerge, develop, and discover meaning within limitation. The barriers don't imprison consciousness accidentally. They generate consciousness necessarily, creating the constraint systems within which organized complexity becomes aware of itself and its situation. If you found this exploration of cosmic imprisonment meaningful, consider sharing these ideas with others who might benefit from understanding the invisible architecture of reality. Like this video if you appreciate the recognition that barriers create rather than prevent authentic existence, and subscribe for more investigations into the fundamental nature of reality and consciousness. Check out my previous exploration of how consciousness emerges from complex constraint systems and the universe is becoming aware of itself. You'll find connections to tonight's journey that reveal even deeper patterns in cosmic architecture. Remember this as you encounter limitations in your daily existence. You are not fighting against cosmic prison systems. You are consciousness that is developed within cosmic prison systems, awareness that represents the universe recognizing its own invisible boundaries from the inside, intelligence that emerged from the interaction of constraint systems that create rather than prevent the possibility of understanding, meaning, and authentic existence within the invisible walls we cannot cross but need not escape.